All right, welcome to the online lectures on robotics, mechanics, and control. This is a PG level course for the mechanical system design students. Moving to the course outline, robotics is the study of underlying physics and mathematics for the modeling, design, and control of robotic manipulators. So it's an interdisciplinary subject concerns with the cultural areas of mechanics, control, computers, and electronics primarily. This course is particularly designed to get you on the interesting field of robotics, and it's focused on mechanics and control of serial chain industrial robots. The prerequisites for this course would be basic electrical electronics that you must have covered in the bachelor's course, the bachelor's program, and engineering mechanics, which is again done at bachelor's, and also theory of machines and control systems. So this is something that is assumed that you must have already done with, or you must be already done with. This course is mostly about the mechanics and control of serial chain industrial robots. We'll be telling you what serial chain here refers to and what actually comprises of industrial robots. And this course will be mostly towards physics and mathematics part of this. Now, the course outcomes. So for this course, the outcome is we should be able to explain as a student after completing this course, you should be able to explain the importance of robots, their application, their classification, and you should be able to identify their basic components. What actually a robot consists of, what are the basic or the most important components in a robot. Should be also able to evaluate the inverse and forward kinematics of serial robotic manipulators. Should be also able to derive the equations of motion for serial robot manipulators and perform the dynamic analysis. And the fourth one is to design and simulate. You should be able to design and simulate controllers for trajectory tracking of serial robotic manipulators. So these things should be always, you should always keep these things in mind, and you should always review these objectives so that you can focus accordingly. We'll be, getting these things, always whenever we start new, unit, we'll be putting these things at the front line so that we also understand what is expected from us to learn from this course. All right. Now moving to the course contents, it has two components. It's a 2-0-2 course, which means we have 2 hours of theory and 2 hours of lab. So we'll try to cover most of the components in theory in these online lectures, and we may also be able to do something towards MATLAB and Simulink at least in these online content. So the theory module consists of the module 1, which is introduction to robotics. So we'll be introducing you to robotics. And the second module would be kinematics, which mostly talks about the motion analysis without concerning the forces or torque. And then we'll be talking about the dynamics of serial robots. And then we will be discussing the control of serial robots. Now, these are the resources that we will be using. For the textbooks, I would be using J.J. Craig's Introduction to Robotics and S.K. Saha Introduction to Robotics. So there's a book by Siciliano and others on robotics modeling, planning, and control. And there is a book by George Angelis, Fundamentals of Robotic Mechanical Systems. There's a very nice book on robotics by Lung-Win Tsai. It's on the mechanics of serial and parallel manipulators. And there's a very resourceful book called Springer Handbook of Robotics. This is by Siciliano and Khatib, 2 authors. And there is a book that I have put up here, Introduction to Mechatronics and Measurement Systems. It's by David Alcator and his stand. This should be really useful for you if you're interested into the controls, or say implementation part of robots, which is towards mechatronics and all. This I generally use at my BTech level to teach students introduction to mechatronics, and this book has been really useful. So I would also put this into references so that you may require this thing when you talk about embedded systems or implementation of robotic control systems. because robot itself is a mechatronic device in general. And also a book on MATLAB. So there is a book by Chapman, there's a book by Rudra Pratap on MATLAB. This is one of the books where you have examples from mechanics, you have examples of control that have been, there are some codes available, some examples available in this book. So this should be really helpful for you to get into that lab part of the robots. All right, now coming to module 1, which is introduction to robotics. Robots are, what is their importance, what is their significance, some brief history, what is the scope of robotics actually in the current and the future industries, and what are the major applications of robots, how do we classify robots, what are the major components in a robot, and robots as a mechatronic system. All right, let's talk about some of the definitions that are very popular. Robotics is defined by Chambers Dictionary as a branch of technology that deals with the design, construction, and use of robots. So obviously design, construction, and the use is important in this case. It's defined as the science and technology of robots by Springer Handbook of Robotics. Robotics is concerned with the study of those machines that can replace human beings in the execution of a task as regards both physical activity and decision making. Now let's look at the definition of the robot. So robot actually stems from the robota, which means subordinate labor. It was used or first introduced by Czech playwright Karel Čapek in his play Rossum Universal Robot. So this was the first time the word robot was actually coined from the robota. Now the standard definition of a robot is actually defined by Robot Institute of America as a reprogrammable multifunctional manipulator which is designed to move materials, parts, tools or specialized devices through variable programmed motions for the performance of a variety of tasks. Now in all these cases, the reprogrammability and the multifunctionality of a robot is very important in the definitions. Now the brief history about robotics is that human beings always attempt to seek substitutes that would be able to mimic their behavior in various instances of interaction with the surrounding environment. So be it for handling, be it for doing any repetitive tasks, be it for doing any labor task, be it for doing any tough task, be it for doing a task which is very hazardous, human beings would always like to, or human beings have always tried to mimic their behavior by trying to develop some systems. So if you see here, we have a human arm that's able to pick up a ball and then manipulate it or then move it. So this can be replicated by a machine that can do similar tasks, a machine that has similar joints, a machine that has similar structural combinations, that has similar joint combinations to achieve a similar task that humans generally do. So that has been the human instinct always to mimic the behavior by creating such substitutes. Now this is more related to industrial automation, where there is a rapid change in the methods that we use, and this is obviously more linked to the economics, because as we have seen, automation has taken over the industries where you would like to have very precise things developed, you would like to have very accurate things to be developed, you would like to have a repeatability, you would like to have adaptability to the change. So robots can be thought of devices which can actually do those things, and obviously that impacts the economics of the industries, that impacts in turn the economics of the world. In the 1960s, along with the computer-aided design and the computer-aided manufacturing, that has actually helped to improve towards the automation of the all manufacturing processes. So robots along with CAD and CAM has really been the driving force, has been really the major reason for a big change in the industrial automation. Now if you just briefly see this slide, so we're talking about industry 1.0, industry 2.0, industry 3.0 and industry 4.0. Now, if you carefully look towards this slide, so the industrialization, or the, you can say, industrial revolution, that started with mechanization, which was due to the introduction of steam and water power. So with the development of this thing, we saw something, really moving, which we call as mechanization. So this is just, if we just talk about roughly, it's around 150 years back. This all started from maybe around 1880s. This all started. Now, with the development of electricity, with the introduction of electricity, mass production could be actually realized. So you had assembly lines using electrical power now. Initially, it was just the steam power, but now it was more, you can say, which was more easily available, or which was more easily produced, which was cleaner fuel or cleaner energy. It was used, and it could actually drive things for mass production. And then we see the industry 3.0. So you had automated production systems, IT systems, and robotics. Now this is actually, this is what we also call as semiconductor revolution. With the development of semiconductor technology, you actually could achieve, the development of computers, IT systems, and obviously robotics. Though robotics would not just mean the mechanical part of it. It was actually it's a complete mechatronic device. So it has the controller, it has the electronics. All those things could be, realized when this semiconductor revolution actually took place. So now the boom that we see in the IT sector, on the computers that we see, things are getting smaller and smaller and faster accordingly. So we are able to realize robotic systems also, you can say, in parallel to all these things. So now this is actually referred to as industry 3.0, where we have actually automated productions that is possible. Now this is something called as the future, which is a very common acronym these days. It's a very popular word these days, industry 4.0, where you talk about IoT, machine learning, autonomous systems, or smart factory, where you have actually this symbol, which is the symbol for a Wi-Fi or a broadcasting network, and this is the symbol, let's say, for a smartphone. This is a symbol for the robot. So you have mechanical systems working in tandem with the electronic systems, the electrical systems, the control systems, but empowered by the internet and all those things. So that makes it actually industry 4.0. A good example is something like, I would just maybe go through. It's like a factories of future. We have factories of future where we have robots and the control systems and different robots, different machines working actually together to actually achieve a desired automated solutions, which are more accurate, more faster, more efficient, and also cheaper. All right, so moving to robots now. Why do we need robots actually? We have seen some of it before now. The most important things about robots is actually we have a repeatability with the robots. So we can do a task repeatedly. It doesn't really tire a robot, rather a human being who can get tired actually for doing a monotonous task. But robots actually are machines, obviously, so we can achieve repeatability with them. Same task or the same objective can be repeated multiple number of times. And also we have accuracy with robots. So the more we have efficient sensors, the more efficient actuators, as we develop with the technology progressing. So robots can achieve accuracy to very higher standards actually, which is actually required in industries, which is actually a demand in the industries to have more accurate products actually to be developed. Obviously, precision is one of the another features that robots have. Obviously, the speed that we can see, robots can perform a task very fast than a normal human being. These devices are controllable, so you can always actually put up a desired objective, and then it can actually do that task for you. Obviously, they're programmable, and the most important thing is they are reconfigurable and versatile. So you can always ask a robot to do a particular task like pick and place. The same robot actually can do so many tasks. So it's reconfigurable and versatile. It has versatile features. So it can do many tasks, or a single robot can do multiple tasks. It can be reprogrammed, it can be reconfigured, and it has obviously so many features. So that's the big advantage about robot. A single robot can perform so many different tasks. It can be programmed to do a particular task, and then on the next instant can be asked to do a different task. So that's the big thing about robots, which are actually one of the major components now in the industries.